Oi. So welcome to scaling communication via continuous integration. I changed the opening slide from what you saw in the program, but I still maintain this one picture, and it's of an interesting stoplight. So around the 1920s, automobiles got quite popular, and we needed some way to be able to communicate to people that, hey, you're sharing the road with other people, and you can't just keep driving through intersections without possibly getting T-boned or something else. Well, we have a normal symbol for this that communicates this, and it was the four-way stoplight. Top right corner, if you notice, it has the red light on top and the green light on the bottom. This one doesn't. There was a reason for the standardization, and it's gotten, turned into a support the colorblind. But back in the 1920s, not so many people cared about people with color blindness or other disabilities. And there was this one little Irish town in Syracuse, New York, that saw the British red above the Irish green and freaked out and stoned the light every single time they would keep putting it up. So they are privy to having it upside down. So what analogy would I even be drawing from this? It's that there are many things that communicate to us what we're supposed to be doing, and we heed them. But sometimes, depending on your situation, it might have to be different than in all other situations. So I'm LB Denker. I have this wonderfully pompous title of Anthropologist of Developer Culture, which is another thing I changed since they wrote the biography in the book. And yes, I did actually say anthropologist. Now, it's only sort of. I do not have an anthropology degree. I have mathematics and computer science. So what am I doing talking about that? Well, my official title on paper is something like senior software engineer, but I feel it's kind of a disservice for me to use that title since I very rarely ever do feature development, core work all the time. I tend to support driving the culture forward. The other thing is I work in the test and automation area. I work on continuous integration. That's why this talk is going to cover quite a bit about continuous integration. But I don't write anybody's tests, and most times when you say software engineer and test, everybody's like, oh, all you do is test all day. And actually, I only test whatever I'm doing. I don't test other people's stuff. Everybody else can test their stuff, right? So anthropologist, sort of, but I do participant observations, interviews, and surveys. I actually look at what the developers are doing on a regular basis. What is tripping them up? And my case study is the Etsy development culture. I work at Etsy. And at Etsy, we recently published a blog post of the Etsy way. And it is so many times mentioned, culture, culture, culture. Culture is what actually drives our development process and how we move forward. Now, acquiring culture, that quote said that it's kind of hard to teach culture, and it is. But we all learn culture as we're growing up. You're in your house. If you grew up in a Catholic household, you learn all of the rituals of being Catholic, for example. And you learn stuff from socialization. Well, part of our developer culture is that we always be pushing. So I'm not sure if you've heard about it, but I would strongly encourage you to read our Code as Craft blogs for it to hear about how we do continuous deployment to a radical extent. We're also very big on developer happiness. We want our developers happy. Happy people do better work. And the biggest thing is we have to trust the people. We have to trust everyone. Now, it's a very risky thing to hope for, right? Because we all make mistakes. Not everybody's always on the same page, but you have to trust them or our system doesn't work. So anyways, getting back to anthropology. Anthropology demands the open-mindedness with which one must look and listen, record, and astonishment of things that one wouldn't be able to guess. And this is the story of all of those things I never would have guessed you could have done. Who would have thought that a couple of guys that had done continuous deployment at Flickr with a very small team in a shared development environment would actually get to go to a company and I would get to work with them and we'd actually be able to get 100 programmers to actually deploy in 20 minutes or less, 60 times a day. So, deploy needing all the pushes. Not sure if you've heard of it. We did open source a deploy tool. So if you are one of those people that have heard about continuous deployment and know about the idea of you need a one-button deploy system, you can grab this deploy in it. Or you can just make your own web page with a button on it. Doesn't matter. It's just something that encapsulates all of the logic and programming that you need to do to actually get your information on the servers. Some good things, logging, monitoring, but because we have to trust all the people, no child safety locks. So if you get in and you can actually go to this page, you can push any of those buttons whenever you want. But we trust you. Why would you do something so stupid? And besides, we can fix it. It's only going to take 20 minutes for us to fix it. And we mean anyone can deploy. We have board members that do it. And we're to 20 minutes or less. But it wasn't always like that. So continuous what? I just talked a bunch about continuous deployment. But there are 3 common things that people talk about with the word continuous in front of them. They can be considered different. There is continuous deployment, which I just talked about, push new code to production, and basically anyone should be able to do that. Or pretty much anybody that implemented code should definitely be able to do that. Continuous delivery, we're not really going to talk about too much because that's kind of a product-driven thing. That's like, how often can you deploy new features? And deploying new features doesn't necessarily correlate to deployment. And what we're going to talk about mostly now is continuous integration, which is applying quality process. So yes, you can apply the quality process every single time you do a deployment, but to really have continuous integration, you should be doing it more than you do deployments. Unless, of course, you're deploying every 2 seconds. So I also mentioned we were going to talk about some communication. So I thought it would be nice to throw up some communication theory stuff so it sounds like I know something. And we have the basic elements of communication: source, sender, channel, receiver, destination, message, and feedback. If you think about a email, sending the email, it could be considered a channel itself. The sender would be like your client that creates the message and transmits it over. The receiver would be the other person's email client. Destination would be the audience receiving it, and the source would be who would be like wherever the person got the idea from. So somebody read a new book about clean code and they put out a new clean code decree. Yay, that's your source. And most of our communication that we're talking about is going to be with CI as the channel, and it's going to be a goal-oriented communication. And our goals of what we want to communicate via continuous integration is that people should always be pushing. They should have the confidence to just always be pushing. You shouldn't push on red. Red meaning like tests are failing. And believe it or not, for some people it's really hard to get over that, especially if you've got test suites that fail all the time. It's very hard to get over, oh, I need to wait until it's green. You should write clean tests. You should write clean code. And you should trust everyone to do the right thing, because everything has to revolve around trust. So always be pushing. So back 1.5 years ago when I first joined, I literally went around to every single team and said, give me 1 person or two people on your team, and I want to sit down with them and just watch what they do on a regular basis. Part of this was because I was terrified out of my mind because I had just come from a company that had all this shit figured out. Like, they knew what they were doing at the time. Everything was organized. And you use these editors, you use this system, and everything was pre-built, and you didn't have to install anything yourself. Pretty, cool, right? And now it was, cowboy land, had to actually do stuff with unmanaged territory. And so part of it was I needed to figure out what the hell I was doing. I was kind of in over my head. And we discovered a few things that were actually tripping people up. One thing is we weren't deploying that often. We actually were only doing like 1 to 5 deploys a day. In fact, there were days that there were no deploys. And for a culture that was saying, hey, we really want to be able to do continuous deployment, seriously, like whenever, that just wasn't going to work. And part of it was because there was absolutely no confidence. So continuous deployment is a safety net. If you can deploy every few minutes, it is an immense safety net because you're going to screw up. But you can fix it in just a few minutes. But it is completely scary because you push the button, you put something on production, and you might just take it down. And nobody wants to be that guy that took down the server. So it depends on your point of view as to whether or not you feel safer or if you're scared out of your mind. Well, one of the things we found that was a pain in the butt was branching was too costly. So I remember one of the days where a team took 8 hours merging a branch in. Well, all right, do you have continuous deployment if you spend 8 hours merging a branch in? No. And is that one team with how many people, and how many more people are you going to add to the company? That's going to take, at that point, I think we had 7 teams. You basically would have to give everybody a day of the week to do a deployment. And you wouldn't actually be able to grow to have even more teams because soon it would take a month before you ever got to do a deployment, and that's not continuous. So one way that we supported this with the continuous integration is that all the tools in CI, everything that ran in CI, did not support branches. Not at all. Everything was trunk-based. You had to work on trunk, and if you worked on branches, you're an expert. Good for you. And you're going to figure out how to keep up with everybody else who's not doing branches, and if you can, awesome. If you can't, well, then you're going to go back to trunk. The other thing was with repo layout and branches, we also had a bunch of tools that I would say smelled like unicorn. So they did lots of magical things and removed everyone from actually knowing what was going on. And so the other takeaway was write transparent tools. Another thing that was a problem, as I mentioned earlier, continuous integration and continuous deployment aren't necessarily the same thing. And they couldn't apply the quality process continuously because it was coupled to the pipeline. So we introduced this concept of try, which was simply, at the time, oh, we'll take an SVM patch file and send it to the server. And where this actually grew out of is once we got a test team, we got resources to run tests, and as in machines. And people were like, I can't run this test on my developer VM. So can I just borrow some time on the test server? Because that's pretty BA. It's pretty awesome. And so before you knew it, someone said, oh, yeah, just SSH into that box and have at it. And then told another person and told another person. And before you knew it, there were a couple guys on at a time stepping on each other's toes. So we used parameterized builds in Jenkins so that we could pass a file over that was a patch file. And voila, they had the experience of running on the CI software with what they were soon going to commit without having to block the pipeline. Before, they would just be like, well, I couldn't run it on my machine. I'll put myself in the queue for the pipeline. I'll go do a deployment. And I'll try to run my tests. And, well, you know, they might fail because I didn't try them. And it would take a little while to run. And this one ended up getting community enforced eventually because now whenever somebody is waiting to do a deployment, if somebody breaks the build, they're upset. They're like, why didn't you try it beforehand? You had every chance in the world to not block us up. And now you're wasting our time. And so it was kind of nice having, community-driven effort on the whole thing. And this try thing was our biggest confidence boost. This is like the number of deployments that we were doing. As you can see, it's like bouncing in the 5, maybe up to 10. But then as soon as we introduced the try server, huge spikes at the end. We started actually deploying code somewhat continuously. So, as I said, why try? Because we don't want to clog the tubes. And it just moves CI to being, as in CI without try, into being just the final sanity check. So, goal achieved, always be pushing. So, you should not push on red, denoising the communication channel. This one was kind of over participant observation over IRC, because we'd be watching people in the deploy pipeline, and a test would break, and people would be confused. Partially because it took a long time to run, but it had a high flakiness factor. The test would fail like half the time. Why? They were full stack tests. They had to go over an SVN tunnel to EC2 instances, whole bunches of points of failures to make them very flaky. And there was practically no one that knew what the tests were testing or how to fix them. So there would be a lot of time just spent during a deployment where people would be talking, saying, hey, this thing broke. Do you know how to fix it? Do you know what to do? And so this would get even worse as you got more and more people. At this time, we only had maybe 40 engineers, and now we're to 100. We're more than double. As you get bigger, it gets harder to know who's that guy that knows what that feature does. It's a very difficult thing to do. So what you need to think about is if you are going to have tests and you are going to make sure that you're not pushing on red, you need to make sure you know what is being covered, how much is being covered, how do the tests work, and most importantly, you need to have actionable test results. You need to have test results that tell you something to do, something to fix them. If you have tests that just flake for no reason and the action item is rerun the tests, you're doing it wrong. So our actual solution to this, not very glamorous. We deleted all the tests. And someone is probably thinking, you are really crazy. You just deleted a whole bunch of test coverage. But the thing is, if you don't know what they cover, then that is zero coverage. It doesn't matter. You were wasting your time. You would have been better off spending all of that time you were waiting for that, rerunning it, doing a manual test all by yourself. So no pushing on red, because the tests were passing on a regular basis, or close. So writing clean tests. Alternative teaching methods. So when I got hired for the job, I had actually spent 4.5 years teaching the developer testing course at my previous company. So probably once a month, I would teach all new hires what they were supposed to do for basic unit testing. And I walked into these guys and tried to teach them. And the immediate response was, we can't do that. There's no way we can do that. And so that was like, OK, well, obviously, teaching you some things isn't the right thing, because you're not ready to get on board with this. It's a totally different style. It's totally different thinking from what you're doing. And that's just not going to happen. So had to prove to them that having actual unit tests and separating them from your database tests and not using crazy integration fixture frameworks that provide random data actually makes a difference. And if you remember from a couple slides ago, I was saying the platform test failed on probably about a 5% basis. And oftentimes that was just in setting up everything to get those tests to run. The unit tests, 10 seconds of test time. Barely any time per test. And then the DB unit test, 32 seconds. And these are all a far cry from 7 minutes. Well, it's still about half for the DB unit compared to the platform test. And once we showed them this data, and we showed them a couple other test suites, like test suites with cache, test suites that use time, test suites that had sleep and whatnot, they were pretty much like, oh, now we get it. That makes sense. And now our unit test suite has grown to 8,000 tests, and the DB unit test is probably at like 200 or 300, so not too much, not too crazy on the growth. Still 4 times, but not too bad. And we enabled this by really stupid stuff. We didn't do too much work. PHP unit has an @group tag. So basically all we did was every single test that touched the database, we went @group database. If it touched the cache, @group cache. If it had a sleep in it, @group sleep. And once we did that, we could just use PHP unit XML configuration files for include groups and exclude groups. We wrapped stuff in a PEG file just because, you know, we had a little messier stuff with environmental variables. And it gained us, one, teaching people that it is faster to write unit tests. And you can get the coverage pretty high up. And 2, it also enabled people to see single points of error. So network tests. Network tests would be something like, I'm talking to a third-party service, something I don't control. And I've heard the horror stories, and I'm sure some of you have horror stories of people just, you know, as a third-party service provider, deciding they're going to change their API on you. Or they're not going to have the uptime they need, and you didn't, you know, program to have your server robust enough to deal with that. Well, if the network tests are all failing for that one third-party service that is touching, guess what that tells you? That third-party service is down. And it's pretty quick and easy for you to then decide, well, we're not going to use the network tests in the deploy pipeline because they're not giving us accurate data right now. It's some other thing that we're going to have to fix or wait out. And that was good. The other thing we had was a flaky test silo. This one took a little bit of convincing. We got people on board with the whole like not push on red, but then there was still people that felt, well, every test is sacred. That's really the feeling that they had. And so we had a flaky group as well. So if a test you just saw flapping all day, like it would go red, it would go green, no code would be touching it, we actually just let them silo it. And eventually, they voted with their feet by not fixing them, and we deleted them. And now, we don't really have a flaky test silo because barely anybody writes a flaky test anymore, which is good. Of course, this led to other problems. Too much to read. We had how many groups on that last slide? Like 7 groups. And if you look, this is a Jenkins page, and this was our front page. So we had like integration tests, unit tests, some functional tests, some smoke tests, and this got really confusing. And even though we had like this entire documentation, nobody reads documentation. Really, some people do, but most people don't. So it's not important that you can actually read that page, but this got confusing. It got further confusing because we were, you know, communicating in IRC whenever tests would pass and fail, and with 10 jobs running per like QA deploy, how many messages do you get in IRC? A lot. And that got too noisy. So if we want to have CI being able to communicate properly, we need to, you know, clean things up. Emailing people what the things were, that doesn't always work. Why doesn't it work? Some people aggressively filter. Some people don't read their emails all the time. And sometimes people just forget what's in an email. Wiki pages, it's kind of hard to get them to go there. And also with wiki pages, they kind of get out of date. How many people have like their wiki page system and there's like 5 different documents on the same exact topic? A lot, right? It's so easy to just be like, oh, I'll just create a new page before I go search for one. It's kind of the same problem you have with bug tracking systems all the time, you know? And we did try doing some information in blogs because it's a little bit better than a wiki because it's temporal and people see the date time and they go, oh, well, that's 5 months old, so obviously, don't bother. So the real answer was we needed to simplify the Jenkins UI. Silent green. So it's kind of a principle out of the XUnit chapter. So XUnit results. XUnit results give you like no information if all the tests pass. Yay. And why is that? Because all the tests pass. What more information do you need? It's when they fail that you need to know what went wrong and how am I going to fix it. So we built a master plugin, we built a deployinator plugin, and all of a sudden we had far more information. These jobs here, they're actually master builds, and we'll be open sourcing those plugins soon. I'm waiting on the security review, I'm sorry. But anyways, these jobs, the trunk job, for instance, when we originally put it out, just has a bunch of checkboxes in the Jenkins config for you to say, yes, run the unit tests, run the DB unit test, run this test, and run that test. And then if this turns red, you click into the job and look at the details, as opposed to looking at that last screen and going like, now which one is attached to trunk? I don't remember. We then also added a deployinator column so that we could actually get in like who did the push and what was the change range of the push, so that if people were just looking at CI during a push, they would have all of the information of what's going on there too. So those were our couple plugins that we added and will be providing on the Etsy.com, the Etsy GitHub. So you should write clean code. Not everyone can read, and most importantly, follow a code standard. I should have also said not everybody can write a code standard. My little trick to it is go find somebody who wrote a readable code standard, copy it, and then change the parts that you don't like. Okay? So clean code. First, you start with syntax. So that's just lint, really. Having lint running, good thing. Then you move on to your style, and then you finally get to your design level. Design level is like the last thing, because everybody feels that they have a certain design style that they use, and it's very hard to convince them that that might not have been appropriate, you know? And so you gotta do baby steps. So PHP lint, make sure people can run it locally, make sure, which they should be able to, make sure they can run it on pre-commit, and make sure that they can, you know, run it on CI. Like, it's good to have it just running in CI. It doesn't take that long. Have it run on the files that just recently changed. That's fine too. Just double check, because it's really stupid getting bunched up just because you missed a semicolon somewhere. Use Code Sniffer. So when using Code Sniffer, this was, you know, kind of fun. Originally, well before I started, they did drop a coding style guideline, and that's where my little quip came from before, where they literally, they sat in a room, they decided what they wanted for style, but what they wrote in the document was the list of sniffs from PHP Code Sniffer, and not actually what they did. And so when I actually ran them, well, then we realized it didn't actually do what you thought it would. But anyways, start with just drafting a coding style guideline. Think of what the ideal looks like. Think of what you've been doing. And this is like, especially when you're like in a legacy realm, like you're not starting fresh. So you have old code, and some of it looks like junk, some of it looks awesome enough. And experiment with the various sniffs, because you know, the documentation isn't always perfect about all the itty-bitty nuances going on in the sniffs. Then start discovering what your actual coding syntax is. You might be surprised. You might think that having the opening brace on a new line by itself underneath the function signature is what you always do, but it turns out that it's what everybody does the least. And is it really worth holding on to that particular style when it seems that everybody has voted the other way? And then, so that's the part where you decide on what changes to the style guide you drafted before was. With that information of what are you doing for privates? Are you doing underscores? What are you doing for public functions? Are you doing camel case, or are you doing underscores in between? And then create a strategy on how to get it green. Because if we want to put the code sniffer to maintain a certain level of style in our continuous integration system, it has to be green. Because otherwise, it is noise. If it is red, it is noise. And people will ignore it, or they will be confused. So the strategy we actually went for is we found what sniffs we were really close on and just fixed those couple up and stuck in a stable coding standard. As in, this is the stuff that the code base passes, so you better not regress from that. Then we stuck in a staging code standard that we put on our try jobs. So it didn't block deployment. Deployment would always be green, but on your try job, you would see the little bit of noise. But at least you knew that that job was separate from the sniffs that you had to pass. So you could look at that and be like, oh yeah, I really should make all of my trues and falses lowercase, because that's what we agreed upon doing. And then, of course, the other option you have is you could do fix-its. If people will let you do fix-its, do a fix-it time. You know, schedule a party, make it a competition. Just, you know, decide what you're going to give the winners for being awesome. And sometimes people just like winning, you know, so you can give them a sticker. So anyways, it's a work in progress. We're still working on that because we still haven't gotten to design. Oh, and blame emails, just to mention, I did try blame emails, as in like I went through get blame for every single line that violated a coding standard thing. And people weren't too happy because if you were the dude that like migrated everything from SVN to Git and somehow got your name on everything, you were a little sad. And sometimes it's very hard to convince people that they own the code when they're coming into a legacy code base. So even though their name is on the line, they may still try to argue with you that they don't own it. So, trust everyone to do the right thing. Balancing enforcement with freedom. So it sounds like with this continuous integration, it's a machine. It just is red or green. It enforces. But at the same time, you still need to feel like you have some sort of freedom. And you know, we're continuously growing, so how do we keep onboarding people, keep the same high quality that we have, if not increase the quality that we have, while not making people feel like they're shackled to doing things a specific way? So we do have more things we need to work on. Code reviews, we're not quite to code reviews. It's one of those things where it's nice to have the second pair of eyes, but at the same time, if you've worked for a company that's like multi-time zone, and you have to ship a code review over to someone, and then wait for them to review it before you can actually put your code in, it just doesn't work. You won't have your continuous deployment anymore because you'll have to be waiting on somebody to review your change before you can actually fix the site again. So it will be interesting to see how we encourage people to do code reviews, and I don't have a good answer yet. Getting to the entire coding standard on CI. We probably, I know that we definitely have everything that would like kick you in the butt. I remember one time Rasmus came in and had a terrible deployment where someone said dark, as in their code wasn't going to be executed. And they changed the signature on a static function, and it had the same parameter listed twice. But how many people can look at a function signature and go like, I see that you listed the same parameter twice? It's kind of hard. It's not intuitively easy, especially when the stack trace you get is something in the PHP unit mock object library throwing up because it can't parse the object to create the mock object. So it gave us the file, but kind of took a little while. Mess detector, going through those standards. That one I'm a little interested in studying. Mess detector, if you've ever used it, is kind of nitpicking on like what your design style is. Okay, and for your design style, as I said, that's kind of hard to deal with people for convincing them. And so it might actually just be worthwhile starting to get reports on what different people, what different teams, what different sections of codes have certain types of messes and see what correlations we can pull out first before we actually start thinking about addressing them. Also strict standards and even doing the PHP unit testing standards. So anyways, maintaining our culture. I've been told I've gone over. I didn't realize it was 45 minutes. Okay, any questions?
Why don't you block your commits for coding standards? You could have a pre-commit hook so that nobody can commit bad code.
Right, except the reason for being against pre-commit hooks, well, so for Git pre-commit hooks, you can force it. Like you can force it to overwrite it. But the thing is, if one little style violation is the thing that's going to hold up pushing a fix as quickly as possible, it's not worth it. So we don't put most of the code sniffer stuff. We try not to make anything be blocking. I think lint is the only thing we have blocking because, well, if it doesn't pass lint checks, it's likely not running.
Hi, I wasn't sure about discouraging people from using branches. I worked in an environment where the developers were not using branches, and what they seemed to do was just hold onto their code and avoid committing it until the last possible moment. So how do you get around that problem?
Right. So the way we get around branching via source control is branching in code. So we have config flags all over the place. We have an A/B framework to set up. Is it admin? Is it 1%, 2%, or whatnot? And because it's behind that feature flag, when you're putting in your little bits of code, you put it behind that feature flag. It's hidden. It's not running. And yes, it's not servicing the full feature yet, but that's OK because it's not executing yet.
The trust bit. Mm-hmm. So trusting everyone in the company. In your team. Let's limit it to the team for now. I can't get over that, especially about people that you continuously say you're doing it wrong, I don't like it, you're not working within the team, and please don't do it again, and again, and again, and again. I don't trust them.
I know.
Basically. Tell me how to overcome my fears.
OK, so partially, I would have to ask, what is it exactly that you don't trust? Is it that you don't trust them to produce something that's working, or that you don't trust them to do it the way that you would want it to be done?
Both. but mainly because they make all the time the same stupid mistakes. Okay. That's what's the more annoying thing. It's not when they learn on the mistakes. I don't mind. I can trust it because I know that when I tell them, the next time they're gonna do it better. It's more about telling them, coaching them, teaching them how to do things, and they still don't do it.
Okay. Another thing is, do they have the opportunity to fail hard? Because part of our trust is facilitated just by having the whole continuous deployment. Because if they are deploying and can possibly break production, a person can only break production so many times before they feel really bad.
It was just more of a comment just on the whole kind of allowing someone to break production. I think it's quite a good idea, but in practice, from a business sense, I don't think my manager would certainly be too happy if I allowed my team to break production continuously. So are there other alternatives to that?
Maybe you need to sell them better. Because, I mean, we are showing that this does work, and it works with 100 people working on the same exact code base, not 100 people on separate teams with separate deployments. And as you can imagine, the more people you get, the more chance you have for people just stepping on each other's toes. and other silly things like that. And so it's best not to word it as giving people the opportunity to break production, because yes, nobody's going to buy that. Oh, it's great if you let everybody just break production. They should break it every week. No, nobody likes that. It's probably better off to look at what kind of uptime might you get instead. How often do you have a break right now? How long does it take you to fix it? So how long is it that you have spent on downtime and on errors being present on your page? Now, if you go look at a model where people can push fixes continuously, how often do they break? Turns out that, at least in our situation, they break just about the same as they would on another site. But it's in shorter increments, so we actually have better uptime and a better chance of not having errors persist on the site. So you might just want to try figuring out different ways to sell them on the whole deal. Otherwise, the alternative, if you don't have continuous deploy, you're going to have to spend a lot more money on quality control. You're going to have to actually spend the developer time on double checking everything at the last minute or getting lots of manual QA in, and that actually costs a lot more than the few minutes that your site's down.
Yeah, you sort of, I'm over here, sorry.
Cool.
Yeah, you partly answered my question actually, but I was wondering about how smooth the rollback process is and how you test that. Like, do you ever go back 2 revisions, say, or 3 revisions? How do you test that? What if the sort of the bug involved data change, say?
So we technically don't have a fixed rollback button. What will typically happen is someone will get to the staging server point, and if they notice that it's bad, everybody who is in the deployment, and it's usually a handful of people, will look over what is the bug and what were their commits. At the start, some people will just start doing a git revert on their change list and push the reverted change and try again. In some situations, if it's really bad that people can't figure out why the logs are off the charts, the graphs are going crazy, then they may just roll back every single change in a range and push that again. And it's the same thing as doing a normal push because it's just a change.
We've got, I think, time for just one last question.
You mentioned briefly about having an A/B test framework or a 1%, 2% deployment framework. How does that work with your CI testing? So if I put a feature flag on something and say, this is dark, I don't want this to be public in production, are you still running tests against it? If the tests fail, does that turn CI red? Does that prevent deployment?
So that all depends on who's writing the test. But you can completely unit test that. The A/B framework, the whole 1%, 2%, that is unit tested. So we know that that entire ramp-up mechanism works. The code that is inside that block, people can write unit tests, and they can go and tweak what the response is on the A/B framework, mock out the A/B framework and tweak the response to be like, in the 1% case, I expect this test to work. So it is just a combination of unit testing and piecing everything together, and that will be the coverage that you would get. The other part that I didn't mention, because it is and it isn't part of our continuous integration / deployment, is that we have lots of monitoring in the form of graphs and logs. And people watch those on production in Princess deploys. So if the whole ramp-up thing does cause some sort of load failures or erroneous log messages, it's very easy for us to just push the config file yet again to turn off the feature. Okay.
Okay, thank you very much.
Yes.